In this video, we're going to cover operator overloading within Kotlin. Operator overloading is basically the concept where you can overload a particular use of an operator, such as multiplication, addition, range, comparison, anything like that. The general use case of this functionality is that it makes code easier to read if you're dealing with something like math operations. So think of something like the quadratic formula here. It has some arithmetic operations in order to get a solution, and if you were to write that in code like this, it's not always intuitive what's going on, versus if you write it like this. That last version is a lot easier to follow, right? Truth be told, operator overloading can have a bad rap depending on the context. So for example, when Java was being developed, the Java language designers chose not to include operator overloading because it was getting overused in C++ libraries that would make it really difficult to figure out what the operator was doing. The goal of the video is not to settle the argument as far as whether operator overloading is the best thing in the world versus the worst thing you could ever possibly do. Instead, what I want to do here today is explain what you can do with operator overloading at a high level within Kotlin. Let's get into it. All right, so to demonstrate operator overloading, I'm going to do some very simple math operations on a point in space. And I'm going to use two dimensions here just to keep it straightforward. So I need to make a class that indicates a point in an XY axis. And then I'm going to have this main function, which is going to do a few things on it. To start, let's go ahead and add 2 points together. Okay, now that we have this concept of this point object, and I'm just going to pass in an X and Y coordinate here within the constructor. And how I'm going to do that is I'm going to make point a data class, which has X and Y as listed here. The basic idea of a data class is something similar to a record within Java, except with a data class, you can also have mutable data members, whereas records are always read-only data members. So you get a lot of things for you, such as equality, hash code, and toString automatically for you from the compiler. And in this case, that's all I really need because my data class is just going to have an X and Y coordinate, and I don't need much else than that. So I think this is a good case for a Kotlin data class. The first thing I want to do here to demonstrate operator overloading is we're going to add P1 and P2 together, and we're going to print the value that results from that. Should be pretty simple, right? We just use this plus operator, but the plus operator is not defined for the point class. That's what Kotlin is telling us here. The way that you define a method which is an operator overload is you have to preface it with the keyword operator. This is only really true when you're not overriding an operator overload, but when you are overloading an operator, you need to specify operator here. Then a note, this is a function, and then now I'm going to ask IntelliJ for the list of operator overloads that I could be using here. And this is the list I get here. Increment, get, compare to, contains, etc., etc. You might think that you want this Unary plus here, but you actually don't want that one. What you instead want is you want plus. Unary plus is when you have a single argument and you want to get the value of the argument, whereas a plus indicates that you are adding two things together. So you want to overload the plus function. And then now we need to define what the other element is that we're adding to our current point. So in this case, we want to add 2 points together. So I'm going to call this point. And for the output of this function, I'm basically going to have it create a new point that adds X and Y together for each of the values, like so. I'm going to make this a little bit smaller here so we can read it. So basically what we're doing here is we're using the shorthand of functions so that we don't have to declare a body or anything like that. This is the equivalent of saying that it's going to return a point type and then having a single line return, which does this. The X value here is going to represent the local property we have defined within the point class. And then the point.x here refers to the local variable point, which is now the X member here and the Y member here. A little confusing when you first read it, but after you look at it for a little while, it should be relatively intuitive. When we switch back to the main class, we can see that the error has gone away. So let's go ahead and run the code and see what it does. Excellent. So we can see that the output here has an X value of 4 and a Y value of 7. If you just do some quick addition here, you can see that that does add up. Sweet. So now we've talked about addition. Another one that gets used frequently is the pre or postfix increment operator. Let's go ahead and do that one next. So to do that, I'm going to show the difference between P1++ versus plus P1. So to start, let's do plus P1. So to do that, we need to define the increment operator. And then in this case, what I want to do is I want to say point equals x plus 1 and y plus 1. Now, what do you think is going to happen here? Is it going to print out the new value after the increment has happened, or is it going to print out the original value? As we can see, what it's doing is it's doing the increment first, and then it's returning that value, and then it's printing that point into the print line. So you get 2 and 3 here, which is 1 plus 1 and 2 plus 1. Now, if we change this to a post increment, and we can already see that the IDE is giving us a warning here. Let's go ahead and see what that looks like instead. Now we're going back to where we print out the original values of 1 and 2 here within P1. So just a quick reminder, with a postfix, what's happening is you take the local value of P1 and then you use that in the expression. Then you take a value of P1 with the increment operator applied to it, and then you set that new value equal to P1. In the case of the prefix operator, what that's going to do is it does the same thing, except the order is a little bit different. So it takes the value of P1, it applies the increment operator, and then it assigns that value back into P1, and then it does the rest of the logic block. This gets into a little bit of operator precedence. Operator precedence in general follows what you would expect mathematically from the "please excuse my dear Aunt Sally" thing you may have heard when you were in grade school, where you have order of operations when you're executing mathematical operations, such as you're going to do multiplication before you do addition. In the same way also, you're going to always process a pre or a postfix very, very early on within the expression processing timeline within Kotlin. I actually think it's one of the first things that the compiler does. But the order in which the compiler does the reassignment into the variable is very different depending on whether you're looking at a prefix or a postfix. Another common one you'll see is when you want the negative of something. Something like this. So in this case, I want to negate the value of P1. In mathematical terms, I need to determine, am I reflecting on the x-axis, the y-axis, or both? In this case, I'm going to reflect it across both just because I want to be lazy and I don't want to determine a particular axis and justify that. So to do that, we're actually going to switch it up a little bit this time, and I'm going to create what's called an extension function. So we'll make operator fun. And the main difference this time is because this is an extension function, I need to define the type that I am extending with this extension function. Dot, and then now I have the list of functions that I can extend. In this case, I'm going to do Unary Minus, and then that's going to be equal to point, -x, -y. And just like that, we've defined now an extension function. So a quick note on extension functions, those are really useful when you've got a library already available and you want to add an extra function to something that you don't have access to the original source code for. Let's say you have like a built-in type or something like that, and you want to extend it yourself within your own library. Extension functions like this are really helpful for that. So the reason that I chose an extension function here is not because of any functional reason, just to give an example that you don't always have to define your operator overloaded functions within the actual class definition itself. So now if we go back to the main file and we run this example, we can see that we get the negatives of the two values that we originally had. So we're essentially reflecting across both the x and the y axis. And also we can see that if I do a negative of a negative like this, we would think that we should get the original value back, right? And we do, yes. So now for the next example, let's think about how we would compare 2 points. Let's say that I want to ask if point 1 is greater than point 2. From a mathematical sense, there isn't anything that's super obvious, but the one thing that comes to mind for me is if these points represent vectors and I want to see which vector is bigger, I would look at the magnitude of the vector to determine if the vector is larger. And the way that you calculate the magnitude is using the Pythagorean theorem, because we're looking at a right triangle here where you can get the hypotenuse of the right triangle. So let's update our point class to get the quote-unquote magnitude of this point if this point represented a vector. And the formula here is going to be the square root of x squared plus y squared. So I want to do x.pow, and I'm going to use the extension function here. And then I want to add y.pow. Actually, I could just use the integer variance of these. And then I need to wrap this whole thing in a square root. And that is the magnitude property now of our point. In my main class here, I want to print out if P1 is greater than P2 from a magnitude perspective. That code would look like this, where I use the greater than symbol here. So to override greater than, all I need to do is define the compare to function, and that covers greater than, less than, greater than or equal to, or less than or equal to. So let's go ahead and do that. Operator compare to. I'm going to compare another point. And I'm going to set this equal to the magnitude comparing to other point's magnitude. So effectively what I'm doing here is I'm redirecting the compare to operator to comparing the magnitudes directly. For the documentation here, a value of 0 indicates that the two values are equal. A negative value indicates that it is less than the other, and a positive value indicates that it's greater. One really quick note on comparison of floating point numbers, you got to be really careful with that because equality of floating point, or especially double precision floating point numbers, is really difficult to get right. And I wouldn't recommend looking for equality. I would recommend just looking for greater than or less than relationships. And indeed, we can see here that the magnitude P1 is smaller than the magnitude of P2, aka the square root of 5 is less than the square root of 34. Now the next thing I want to cover is, let's say that you want to access data members within your object and you want to access them via those square brackets like you'd associate with an array. Something like this. In order to use the index-based lookup operators like this, you really need to implement two different operator overloads. The first one is for getting the value, and the second one is for setting it. If all you need to do is get it, all you need to do is override that first one. And same thing for that second one. But in this case, I want to go ahead and do both. So within our point class, what I need to do is I need to override, in this case, the get operator. And the parameter I'm going to pass in here is going to be the index, which refers to the index within the brackets that I'm looking at here. I could pass in some other data type, but in this case, I'm just going to use integers. And then I want this to return a double. So let's make a few different rules depending on what the index value is. So when index is equal to 0, what I want to do is I want to return x. When index is 1, I want to return y. Else if it was neither of these, then I'm going to want to throw a runtime exception and say invalid index. So if we run the code as is, we do get that x coordinate out of 0.2 here. If I do something out of range, we get the runtime exception as expected. And now let's say I want to do something that a language like Python has, which is negative indexing, which indicates to start from the back of the list. If I do this, let's see what happens. It also throws a runtime exception. I could go ahead and fix that really quick. So I don't particularly love this solution right now, but if I'm just writing some quick code, I would do something like this, which says for either a value of 1 or for negative 1, I'm going to return the value y. Let's go ahead and rerun the code and verify that. And lo and behold, that is what we get. So now let's say that I want to set the value. I'll set it to 1.3. Now I need to implement the set operator here. I'll go ahead and start with the same outline, but we are going to change it up a good little bit. So now I want to implement set. I have my index, and then now I need to also indicate the value that I'm passing in here. So value, which is going to be a double type. I don't need to return anything. I could have it return unit like this, but I don't want to do that. Instead, what I want to do is no return statement. And then now I'm going to say when it's 0, x equals value. When it's 1 or negative 1, y equals value. So what I'm doing here is I'm actually changing the underlying properties of the point object that I'm actively using this operator on because it's a setter, right? Let's go ahead and print out the new value of P2 and make sure that our changes persisted. And we can see here that they do. The new value of x is equal to 1.3, y is still equal to 5. Cool. There are other operators that you can overload, such as multiplication. And in general, I really like operator overloading if it's used properly. That's the really key point. For example, if I were to define the product of something and I'm talking about a matrix, which type of product am I referring to? A dot product, a cross product, all the other different products that a mathematician could tell me about, I would have to define that within the documentation. It's not inherently obvious which one I'm referring to when I just use a asterisk to indicate multiplication, right? So that's where I think operator overloading can break down a little bit, but in more simple use cases like this, I think it works great. So what do you think of operator overloading? Do you think it's this awesome thing that Java is missing out on? Or do you think it was better to completely omit it and Kotlin made a mistake including it? Let me know in the comments. If you're looking for some more general information on how you write code within Kotlin and how you can kind of get started, I'd highly recommend you check out some of my earlier videos on that topic. Thanks again for watching. I hope you have a good rest of your day, and I hope to see you next time. Take care.